Welcome to Personal Science Academy classes, and we are once again here with one of the numericals for class 11th physics regarding the connected body problems. And it's given that in this Atwood's machine, the system starts from rest. What is the speed and the distance moved by each mass? Time is equal to 3 seconds. So before that, let's find the acceleration of the system so that we can find out the speed and the distance moved by each mass at time is equal to 3 seconds. So in this case, let's consider the free body diagram of this mass m into g acting vertically downwards because this mass is greater, so acceleration would be in this direction. So this is the acceleration, the direction of the acceleration, and let's consider the free body diagram for 10 kg mass. For 10 kg mass, the mass is acting vertically downwards. This is the tension T in the string. So the net force on 10 kg mass, we know that the force on, let's say this is an object A, force on object A is equal to, because the tension is greater, so we will subtract the mass weight from the tension, and force on mass A will be mass of the object A into the acceleration of the system. This is T minus, this is mass of the object A, which is 10g, and this is also 10 into A is equal to T minus 10g. Let this be the first equation. Now let's consider free body diagram for B. The free body diagram for object B that has mass 12 kg. Now its mass is vertically downwards. This is the tension T. Okay, now the acceleration is downwards, and the net force on object B, this is object B, is equal to weight is more than this is mass of object B minus tension. So the force on object B is equal to mass of object B into acceleration of the system, mass of object B, G minus T. Let's put in the value of the mass of object B, which is 12 kg. So this is 12 into A, 12G minus T. Let this be second equation. So we have equations 1 and 2. So I'm going to write the equation 1, that is 10A is equal to T minus 10G. And I'm going to write the second equation, that is 12A is equal to, this is, I'm going to write this negative T first, and then plus 12G, and then going to add these two equations. So this gives me 22A is equal to, this gets cancelled, minus 10G plus 12G is 2G, this is 11. So acceleration of the system is G by 11. G is acceleration due to gravity, so this is 98 by 11, and I can write it as 98 by 110 meter per second square. I'm not going to calculate this because this is not asked in the question. So let's straight move on to what is the speed. So speed is given by velocity acquired, that is, and it's given that they start from rest. The system start from rest. So that means the initial velocity of both the masses is 0. So for the system, it's v is equal to 0 plus acceleration is 98 by 110, and it's been asked that we have to find the speed acquired after 3 seconds. So this is 3, and 98 into 3 is 8, 3 that is 24, 9 3 that 27, 28 divided by 110. So if I divide 284 by 110, 284 divided by 110 should give me 2.58. Or I can also divide this 98 divided by 110 should give me 0.89, and 0.89 into 3 should give me 2.67. So I can write it as this is 0.89 meter per second square. So rather than putting this value to get the precise answer, because the answer for this question is velocity is 2.67 meter per second. And to get this answer, I have calculated A to be 0.89 meter per second square. So I'm going to put this value of A here, that is 0.89 into 3 square. So this gives me 0.89 into 3 square is 9, and 0.89 into 3. So 0.89 into 3 should give me 2.67. So this is 2.67 meter per second is the velocity of system after 3 seconds. Now we have to find the distance moved by each mass. Time is equal to 3 seconds. So we are going to use this equation. S is equal to ut plus half at square. So distance moved u is 0, so 0 into t, and this is half into acceleration is 0.89, t square is 3 square. So this gives me distance is equal to half into 0.89 into 9. So I can cancel this with 2. So distance is now 0.89 into 4.5 meter. And if you multiply this 0.89 into 4.5, that should give me 4.005, and I can take it as 4 meter. So with this, we are done with this numerical. Do like, share, and subscribe. Thank you for watching.